Okay. Hello, everyone. Good morning. Thanks for joining the talk. I am Piyush, and I'll be talking about OPFS. Is it the next evolution in web storage, or it's just going to be another experimental tech? That in web world is very common. Like you see many tech coming in and going out as quickly as it came in. So before I deep dive into OPFS, what is it? Like, has anyone heard of it? Has anyone used it? I would like to know that. So for that, I would request you to take out your phones and we'll run a quick poll. So just give me a second. Yeah. Yeah. Could you please join the link? It would ask you to fill out your name, and then we'll probably see over here the audience. Okay, I think it's a bit difficult. Okay, I see that a few people have joined now. Okay. Yeah, so you can probably click on one of these options and submit. So we have never heard of it. Never heard of it. That's expected. Never heard of it. Yeah, so if you are tapping over there, there's a submit button as well. So you remember to submit that as well. Okay, so it's 11 never heard of it out of 13. So let's see if we have like the other two as well. Okay, probably it's a duplicate entry. But yeah, I got the gist. Essentially, no one's heard of it. And that's actually good for me. Now I can say anything, and you would have to believe. So I'll move on. Yeah. So what is OPFS? OPFS is Origin Private File System. It's a file system within your browser that's private to an origin. And I'll explain origin first. What's origin? So origin is constituted of the scheme, which is HTTPS, and then the domain or the host name, which is example.com, and then the port. So that's an origin. If you were to compare it with other origins, for example, in the first example, it says evil.com, which is different from example.com. So it's not the same origin. Next one is example.com, but the origin A is www.example.com. So it's a different subdomain. And then the next one is also a different subdomain. The next one is a different scheme. And the next one is a different port. The second last one, it's the same. So it's same scheme, same host name, and the same port. The last one is interesting because it doesn't specify the port, but because you're using HTTPS, so it is implicit that you're using the 443 port. So yeah, that's an origin. Coming back, so it's a file system private to an origin, and it is a sandboxed file system. When I say sandboxed, what I mean is that the files that are stored in this file system, they are not on the user visible file system. For example, when you download something, it goes into your D directory or your downloads directory, but that's not the case in Origin private file system. The location of the files is kind of an internal detail of the browser implementation. So that malicious actors cannot gain access to those files easily. And whatever scripts maybe, whatever script you run in that OPFS, in that origin private file system, that only has access to that particular origin and not outside of it. So that's what sandboxed is. And if you were to look at the diagram, you'll notice there's a similarity between how hard drives store data and how OPFS stores data. So on the root, you see HDD, like the hard drive, and then you have folders, and then you have a lot of files within those folders. And similarly, in OPFS, you get the root directory, just like a hard drive, you get navigator.storage.get directory, and then you have folders and files within the OPFS. Okay, I already talked about that. Yeah, but why even bother about OPFS? Like, what are the benefits? So first of all, obviously, is security. Because the file system itself is sandboxed, a malicious actor would not be able to gain access to your user-visible file system. Second is flexibility. So we have other browser storages, for example, local storage or session storage or IndexedDB. But because OPFS lets you work directly with files, it is much more flexible. You can build libraries, build systems on top of OPFS that would be able to mimic the functionality of IndexedDB as well. Next important one is user interaction. So this is like a cool one because you notice you might have used some APIs, show open file picker or the show save file picker. There's an input button and you have to click on it, and that's when you get access to a file. But in case of OPFS, that's not the case. You just get directly, you get the file handle directly, and you can do whatever with it. So there's no user interaction involved. You can work with the files directly. And performance. Performance is a big thing for OPFS. So you might have noticed when you download files from internet, sometimes Google, Chrome browsers block it. They say safe browsing. Or in terms of Microsoft Edge, sometimes it blocks the files, says smart screen blocked the files. That's because it is being downloaded to the user visible file system. But in case of OPFS, because it's a sandboxed file system, the browsers do not run those checks. So it's much more performant. There are no extra security checks. And adding to this performance benefits, there are in-place rights. So who out of the audience understands what are in-place rights? Like anyone, any idea? Okay, I'll show, I'll just try to. Should I zoom in a bit? Okay, so let's say we have a file, there's a new file and the content of that file is like hello. And if it's a non-in-place right mechanism and you were to append something to it, so let's say I wanted to append world to this hello text, what would happen in case of the scenario wherein it is non-in-place rights? The browser would first create a temp file. So the temp file will already have this content. So it would already have hello, but it's a temp file. Nothing is being written yet to the actual file. And then when you append the text, the world would be appended to this temp file. And when you close the file, when you close the stream, that's when actually the contents are copied back to the to this main file. This is what non-in-place write is. So I think you can kind of extrapolate from there. What in-place write is that you open the actual file and you already know the position wherein the last write was, and you just append to it. So it would directly append to this main file. So it's much more performant that way because you're not loading anything to memory. You're not creating a temporary file. Okay, yeah, coming back. So how do you use OPFS APIs? There are essentially two ways. First is using the main thread, and the second one is using web workers. So I'll run some code. I'll show you. Just give me a second. Yeah, let's open up. For example, let's say open up google.com, and we'll open up the DevTools. Let me zoom in a bit. Okay, sorry. Okay. Should I zoom in a bit more, or is it visible? Yeah, it should be good. Okay, so how do we gain access to the OPFS? So if you remember, I showed in an earlier slide, you do, so I'll just create a variable first. OPFS root, and yeah, I've already did that before, so I'll take help. So you just use the navigator.storage.get directory, and you'll get the handle for the root directory of OPFS. So you now have the root directory. Now let's create a directory within it. So you do OPFS root dot get directory handle, and you mention the directory name. For example, some directory. And if it doesn't exist, you create it. Okay, and because this is an asynchronous API, we have to put await in front. Const directory handle. Yeah, and the directory should be created. Let's confirm that. So I'm using an extension, OPFS Explorer, and you can see that the directory is created. It's some directory. Now, let's try creating a file in here. So we'll do a similar thing. We'll get a file handle now, and yeah. So what we are doing is we are, in the directory handle, we are getting a file handle by the name firstfile.txt, and we are creating the file if it doesn't exist. So let's run that. Okay, let's open up some there. Yeah, so the first file is created, but it's empty. There is no content within it right now. Let's change that. So generally, when you want to write to a file, you create a stream, and using that stream, you write to files. So we'll do something. Const writable stream. So what I'm doing here is I'm using the file handle and then creating a writable stream over it. So one interesting thing happens now. A temporary file is created. This is what I was talking about earlier. When you want to work with a system wherein it doesn't support in-place writes, this is what happens. A temporary file is created. And now if I want to write something to it, let's say, I write hello. Yeah, so you'll notice that the content is not yet in the main file. It is in the temporary file. And if you want to have those changes in your actual file, you have to close the stream. Yeah, so now the changes should be in the main file. Let's confirm that. Yeah, the hello is there. So this is how you would write to a file in case of when you're using the OPFS APIs using main thread. So all of this is running on the main thread. You can use, because I'm running it on console, so it's on main thread. You can do a few other operations like general file handling operations. So for example, let me get the file object. So let's say I get the file object. File handle dot get file. And yes, it's an asynchronous API, so I'll use await. So now I have the file object, and I can get like a lot of details out of this. So I can get the last modified date, the name, size, or even the text. For example, I do this and use await, so I'll be able to get the text out of it. So yeah, that's how you use OPFS APIs on the main thread. Cool. I'll come back. Yeah. Oh, sorry. Yeah. And so this was how you use main thread. This is basically just the code that I was showing over there. And just give me a second. Yeah. But how do you use OPFS APIs in web worker? So has anyone here used web workers? Like know about, oh, amazing. So web workers for, yeah, I mean, I hadn't used web workers before this as well. That was new to me. And web workers are like really special. So web workers are a mechanism through which you can kind of achieve concurrency in JavaScript world. So JavaScript, as you would know, is single-threaded. So whatever you run on the JavaScript engine, it would block your thread. But if you want to have some kind of concurrency, you use web workers. So you can run a script parallel to your main thread, and how you talk to the web worker is through messages. You send a message to the web worker, and you get some data back through a message. So it is a bit different in how you use the API, and also in terms of the performance gains that you get. So the first thing here is that you create a sync access handle. So you remember we already had the file handle in case of async API as well. But now you run an extra operation. You get a sync access handle. So I'm using the term sync. What do I mean by that? What I mean is that whenever after you get the sync access handle and you run operations over it, it would block the web worker. It's not blocking the main thread, but it's blocking the web worker. But that wouldn't affect your application because most of your application is running on the main thread, so your UI would still be very smooth. So everything is happening on the web worker. And how you write text to it to a file in web worker is you use a text encoder, you encode some text and just write it. And it's instantly written to the file. There is no temp file, there is no opening of a temp file, closing of a temp file. It's really, really fast. I'll get to a demo wherein we'll see this in action. Okay, so let's show a demo of how it would work if we were to work with video streams. Video streams are like a really good use case of showing how OPFS might enhance the experience. So, okay. So yeah. So what I'm going to do is, I have created kind of two sets of operations here, one which runs without the OPFS and one which runs with OPFS. So I'm going to start recording. What it would do is it would open up the video stream, the camera stream, and it would start recording. And because I'm running it without OPFS, so it's going to store the recording within memory in RAM. So let's do that. Okay, it should get the permission. Yeah, oh, hello. And now let's stop the recording. So you can see that I can play the recording. It's in memory right now. I can play it, and the recording would be there as long as I don't refresh the page. Because as soon as I refresh the page, because it was in memory, it would be lost, and I do not have access to the recording. That's where, because with OPFS, we have persistence, we have storage on browser. We can store that recording in browser. So let's try that. So it's the same operation, start recording, and hello, and I stop recording. So now I'll play recording. That's usual, but where it shines is that that recording is saved on disk. So this is another plugin I'm using to see the OPFS files. So you can see that a test.webm file is created within recordings folder, and it's of like 1 MB. And even if I refresh the page, close the browser, close the machine, it's going to be there. It's persisted to the disk. So I refresh the page, and it's there. But there's one more thing to it. So let's try recording again. And it's recording, but let's say something bad was to happen. The browser was gonna crash. So I've opened up a task manager, and yeah, I crashed the tab forcefully. I'm just kind of trying out, if a browser can crash, like it can happen at unusual times. So let's just crash the process. So it was recording earlier, and I crashed it. So because it was writing to the disk in real time, we still have the recording. So we can check it out, and the recording should still be there. Yeah, it's like this time it's a bigger file. It's around 7 MBs, but the recording is still there. So that's the benefit of using OPFS. Like you can persist to your disk, and I even tried crashing the tab, and it worked. So you can play the recording, and it would work. Yeah. Cool. Okay. Okay. So Okay, so a question might arise that I used the specific synchronous APIs, like I used the web worker approach in saving that recording to disk. Why not use the async API? So just think of a scenario wherein this video stream is getting huge, which it can. Like for example, when you're recording a video and it's a meeting, it can go over an hour long and it can go into GBs. And if you're storing all of that recording within memory, your browser might get a bit slow, or if it were to crash, you wouldn't have the time to store that recording on disk. Like on a browser crash, there is no event. Like it just crashes. There is no event. So you have to be kind of prepared that you are saving all that data onto disk in real time. So that's why you use the web worker APIs. So yeah, so what do you get out of this? Without OPFS in memory, if the video gets large, it will take up a lot of memory. And it is prone to data loss if the browser crashes. With OPFS, with the web worker approach specifically, the writes are synchronous and they persist to disk, and the data is safe even if the browser crashes. And obviously, it doesn't block the main thread, so your web application would still be very responsive. Okay, why did I think of this specific example of recording a video stream? So me and my friend created a Chrome extension some time back, and it's called Busy. So yeah, so it's a Chrome extension that lets you record Google Meets for free. And it's kind of a screen recorder, but much more suited to Google Meets. So you can record any number of Google Meets. And this was a specific problem that I encountered with Busy. And so let's say I open up a new Google Meet session, and Busy is running. So let's open up a new Google Meet session, and I hit record. So this is the extension. I hit record. Yeah. And as you can see, the timer has started, so recording is going on. So what was happening earlier was I was saving the recordings in memory, and some users started complaining that their recordings were being lost after they ended the meeting. Somehow the browser crashed, or the tab crashed, or some error happened, and they were not able to retrieve their recordings. That's when I started searching for solutions to this problem, that how can I persist to disk? How can I save these recordings so the recording is not lost? So now we use OPFS for that. So if I were to go into the recording section of the extension, you can see that the topmost one, that's the recording. So if I refresh the page, you'll see it is growing by the time I refresh. So it's 152 KB, it's 153 KB. It's being written to the disk in real time. So even if the browser was to crash, something happened, user's recording would still be safe. Yeah, I'll stop recording, and as soon as I stop recording, the recording would be downloaded. Yeah, so that was about Busy. Let's go back. Yeah, now I talked about the async API and the sync API, and how the sync API has much better performance than the async API. Let's try that out. Like, let's see with the benchmark how that fares. So, okay. So what I'm doing here is that I'm taking a file and I am appending 10 rows of data, 100 rows of data, 1,000 rows of data, and 5,000 rows of data. And I'll be comparing the time it takes for the process to write using async API and the sync API. So let's try that with the async API. You'll notice 10 rows, it's really fast. 100, it's fast, still fast. For 1,000, it starts to take time. And in the meanwhile, it's running, let me just show you a cool thing. So you see there's this logs directory in the OPFS. And as I refresh, you'll notice that there's a temp file being created. As I earlier showed, there's a temp file. Every time I'm appending to the file, a new temp file is created. Every time the write is flushed to the disk, that temp file is created. That's why it's kind of getting a bit slow. So yeah, I'll close this, and it's still taking a bit of time to write 5,000 rows of data. In the meanwhile, I can show you how the code looks like. So I'll close this file. I'll close this file. Yeah, and let me just, yeah. So just ignore all of the kind of code, just focus on this one. This is the main function where I'm appending the data to the file. And in this one, what I'm doing is I'm creating a writable stream, as I showcased earlier. Here I create the writable stream, and then I'm figuring out like what's the current position wherein I want to write to the file. And then I write to that particular position. So this is where I write to that particular position, and I close the stream. So that's when the temp file gets deleted and the actual stuff is written to the main file. Yeah, I think the benchmark should be done. Yeah, so as you can see, I've tried to create a pretty graph. So let's compare it with the sync writes. So as you can see, for 5,000 records, 5,000 rows, it has taken around a minute. Now let's try the same thing with sync API. So it's comparable for 10 rows. It's much faster for 100. It's much, much faster for 1,000. And I think you should be just about finished by now. Yeah, so it's like much faster. And there's like, a huge exponential performance gain as the file size increases, because it is not loading the file in memory. It is not creating a temp file. It is just directly writing to the file at whatever the current position is. So, and if I were to show you a bit of code, so for those who have not worked with workers, creating a worker is like really simple. So this is how I initialize a worker. You just give it the script, and then you just do new worker, and that's how you can run some process parallelly. And how do I send data to it? So let's see that as well. So as you can see, just give me a second, write sync file. Yeah, so I'm sending the data from this main thread over to the web worker using post message. So this is the API that's used to communicate between main thread and the web worker. So you then send data over to the web worker, and this is the worker file. In this, nothing special, just a message listener, and in that message listener, I'm getting a file handle, and then I am writing to the file. This is the sync API. So you'll notice there is no await in here. It's not an asynchronous API. It's a sync API. It blocks the web worker, but it doesn't block the main thread. And you just flush the changes, and it's done. Yeah, let's come back. So yeah, that's the graph. Okay. Yeah, so this is the same graph that I was showing earlier. So when you are using the OPFS async API, stream is closed after every write. It creates a temp file, much slower. But when you're using a web worker, there is no temp file. You can directly append to the file, and you gain exponential performance benefits out of it. Cool. So there is, you might be thinking that, why even bother with async API then? So async API is like really good for working with small files, because you don't have to have that overhead of workers. You just directly start out within your main application, and you can work with smaller files. Only when you want to work with larger files, wherein you want to have a stream, that's when you kind of tap into the power of web workers and the sync API. Cool. So let's see how it compares to some of the other browser storages. So we have local storage, session storage, we have cache API on browser, IndexedDB, and then we have OPFS. So what's the storage limit for local storage, session storage? It's like at most 10 MBs, 5 MB each. But for cache API, IndexedDB, OPFS, they kind of use the same quota for their storages. In Chrome, you can use kind of 60% of the hard drive space available per origin. And Firefox has a different limit. It's 10%. Safari has a different limit. It's 20%. The next one is persistence. Like, what I mean by persistence here is that in case browser is running out of storage, Would the browser automatically delete your data? In case of local storage, it wouldn't. You have to explicitly delete the data. In case of session storage, yes, it would automatically delete the data when the session closes. In case of all other three storages, Cache API or IndexedDB or OPFS, you have to explicitly request for persistent storage with this function. And when you do that, for Firefox specifically, the limits change. For everything else, it remains the same, but for Firefox specifically, for Firefox specifically, it increases the limit to 50% of hard drive. Okay, so some other comparison points. So what kind of API is there? For local storage, session storage, it's a sync API. Even on the main thread, it blocks the main thread. But because on local storage and session storage, you work with smaller data set, you generally use it for key value pairs. So it's not really a performance hit. In case of Cache API, it's async. IndexedDB, it's an async API. OPFS gives you options of async and sync API, both, like I showed earlier. Where can you use this? Can you use it in a worker? For local and session storage, you cannot use it in a worker. For Cache API and IndexedDB, you can use it in both. For OPFS, I might be wrong in this one, but as far as I have searched, it's only available in the main thread and web worker, not in service worker. But I might be wrong on that. And what kind of data would you store on these storages? Local storage, session storage, you generally use it to store strings or key value pairs. For Cache API, you generally use it in service workers to cache a fetch request response. For IndexedDB, you might use it to store some structured data, and OPFS is like file-based. You can store anything. And some of the use cases for these storages would be that for local storage and session storage, you will use it to store your app state. For example, there's a filter on your web application, and you want to persist it for the next session. You use local storage to store all those filters, that sorting state. And then for Cache API, you would use it, like I mentioned earlier, cache the static resources, cache the fetch response to make kind of an offline application. IndexedDB, a use case for IndexedDB might be you are creating a messaging application and you want to store like the recent 100 messages so that when a user scrolls up, they don't have to make network calls, and that kind of data can be stored in IndexedDB. For OPFS, it's like really good for streams. I showed an example for video, so you can use it to store that. You can use it for logs. So logs can get pretty huge. Like some of the applications, when they start logging in, they can get into GBs, and OPFS would be a really good technology for that. And because OPFS is a file system, you can build on top of it. So WASM SQLite, it's a SQLite port for web, for WASM, which uses OPFS. So people are building libraries on top of OPFS as well. Okay, let's talk about some of the companies who are already using OPFS. One of them is Photoshop. So Photoshop uses PSD format to store it's kind of the working format for its files, and it gets pretty huge. It can go into like GBs, and it grows exponentially as you do more and more operations. And they were running into problems that they were not able to port that application, the desktop application, to web because there was not a good enough performant file system for web. So that's they tried OPFS, and I'll actually show it to you because that's the good thing about web. Everything is open. You can see, you can just open up the dev tools and you can try to see, how it's working. So let's see. Let me open up Photoshop. Let me zoom in a bit. Okay. Yeah, and I'll open up the dev tools. And I'll open up the OPFS directory. You can see that they're already, like, even when I just loaded the web page, they've already created a lot of files. And sorry, I think I clicked on something accidentally. Yeah, so I opened one of their demos and it's still loading, but you'll notice that by the time the file is loaded, they have created a kind of cache to fasten the performance. And as and when I zoom in or like do operations over this, you'll notice that the file size is increasing. They are like doing a lot of operations so that they don't have to talk to the server to do these all of these operations. They're doing it right on your system. And they mention on their blog that they're doing this because their files can sometimes get larger than what the user memory is. And if you don't have enough user memory, the system might crash and the application might not be usable. So that's how they use OPFS to create a kind of cache for using this functionality over web. Okay. Notion already uses OPFS as well. So they were earlier using IndexedDB for caching while navigation, but they switched over to OPFS and they saw around 20% improvement in their navigation times. And Autodesk also uses, on their online model viewer, they use OPFS, and they mentioned that they gained around 2 to 7x of performance gains just by using OPFS. So yeah, these are some like real-world examples. Other companies might be using it. I showed that BZ is using it. So yeah, a lot of real-world companies are using it right now. Okay, so we talked about APIs, but what's the browser support? So Chromium, as usual, started supporting this much earlier than others. It started supporting the browser storage spec in October 2020. But at that time, it didn't support the web worker API. So interestingly, that the web worker API came in Safari first, before Chrome. So that was surprising to me, because Chrome is usually the one who is ahead in this API race. But Safari shipped the OPFS spec and the higher performance in-place writes with web worker in December 2021. Then in 2022, Chromium started supporting the in-place writes. And then in March 2023, as usual, Firefox is last to the race, and it started supporting the OPFS and higher performance in-place writes. But yeah, essentially, all of the major browsers right now do support OPFS. So this was the current state of OPFS and the file standard, but what's next? So this OPFS, as I mentioned, is sandboxed. All of the in-place writes functionality that we saw earlier, that's kind of limited to the OPFS within the sandboxed file system. But users, developers have been demanding on the community group that why not have this functionality for user visible file system as well. For example, when you work with desktop applications, you're not restricted to a sandbox file system. You can, for example, when you open up Photoshop, you can select a file and it gets access to that file on your D drive or your C drive or like on Mac on that main file system, and you're able to work with it. That's not possible right now in web. So that's what the users are demanding. Let's see how it goes. It's just a proposal right now. One other thing which is a big problem is that there is not consistent browser support for all these APIs. For example, in terms of VS Code dev, has anyone used vscode.dev? It's like the online version of VS Code. Oh, some people. Cool. So I'll show you right now what I mean by inconsistent browser support. So let me fire up vscode.dev. I'll just create a file. Let's say I create a new file and I write some text. Oh, sorry. Yeah, I write some text over it. Let's say I write hello world, and I press Control S or Command S for Mac, and I try to save it. So it asks me that where I want to write it. Now that I've given the access, it wouldn't ask me again. So if I, some more text, I write some more text, and I press Control S or Command S, it would just save it because it already has access to that file. But interestingly, this doesn't work in Firefox. So if I were to open up Firefox, just give me a second. So let's try the same thing. Yeah. So yeah, there's a file that I've tried to create. I write something on it, and when I press Control S or Command S, it's downloaded. That's not a good user experience. It's not asking me where I want to save it, or like it's not showing me anything. It's just directly downloading it, and the Firefox still doesn't have access to that file. If I write something more, if I write some more text over here, yeah, so I write something more and I press Control S or Command S again, it would again download it. Like that's really, really bad. And it's because Firefox doesn't support the APIs right now for some of the newer file standards. So yeah, that's one thing the users have been, developers have been demanding, that we want consistent browser support for all these APIs. Okay, so a recap of what we covered. So we covered what is OPFS. It's a file system private to an origin, and some of the major benefits are it's sandboxed. It gives you flexibility to work with the file system, and there is less user interaction in comparison to some of the other APIs, and it has huge performance gains. There are two ways to use OPFS. One is using the main thread, other is using the web worker. Then we saw a demo of using OPFS when you're trying to record a video stream, and I showed how Busy was the one which inspired this kind of scenario, wherein I encountered this scenario, and it led me to find the solution. Then we talked about logs, in which we compared performance of async API and the sync API. And we also talked about how OPFS compares to some of the other web storages like local storage, session storage, and IndexedDB. We saw how Autodesk, Photoshop, and Notion are using OPFS to kind of gain free performance gains. And we talked about that most of the major browsers do actually support these APIs. And then we talked about how some of the requests from developer community, they drive where the file standard is going. Okay, so we covered all that, but now I guess none of you had heard of OPFS before, but now when you think of OPFS, what word comes to your mind? Let me just open up that link again. I would request everyone to take out your phone again, and yeah, you can, if you already have it open, that's good. If you don't have it, you can just scan it again. Cool, I'll move ahead. So I'll move over to the next question. Yeah, just write a word that comes to your mind. What do you think about OPFS now? Okay, flexibility, limited, that's interesting. You can also like some of the other responses. Dodgy, that's interesting. Useful. Custom cache, yeah, that's interesting. Potential. Okay, so I see that some of the folks have liked useful, so that's why it's kind of bigger than some of the other responses. Yeah, that's cool. That's nice, yeah. Cool, let's move ahead. Okay, I'm still getting responses. Yeah, I'll wait a few more seconds then. Cool, I think I think that was it. So let's move back, and yes, I'm open to questions now. That was for the presentation. Any questions? I'm sure that people would have questions because this was a topic that nobody had heard before. Yeah, go ahead.
If the storage is persisting across sessions, if that user wants to get rid of that, how can they do that?
So if a user wants to do that, probably, you see on top of, for example, if you notice this on the top. Generally, if you want to clear out site data, you can, clear out your site data from here. But if you want, you can also build, a button into your application that can let user delete all that data. Yeah, that's the third part.
Do the standard dev tools show it? Because I haven't seen it.
No, the standard dev tools do not have support to show that OPFS right now. It's in the works, in the community. It's one of the major asks, but it's not there yet. Yeah.
Is there any like future plans to like map that to a physical, you know, if you can map one of them to actually a physical folder on disk?
Physical?
If you can map it to a physical folder on disk, you know, if you like kind of like allow the browser to access like, I know, your C/some folder.
Oh, yeah. So, like I mentioned before, it's a sandboxed file system, so you cannot map it to some drive on your user visible file system. Like, even if you were to figure out where these files are stored on OPFS, Chrome might change it because it's an internal detail. Even if you know it now, tomorrow it might be a different place. So, right now you cannot do it, but users have been asking that, a sandbox file system is kind of limited. You would want a free flow of data within that limited file system and the user visible file system. So that's a request in the community, but it's not there yet. Yeah.
The files it creates, is there a way for a user to download that onto the disk?
Yeah. Like in the BZ as well, those files were in the OPFS, but you have to build that functionality in your application. It gives you the APIs, but you have to build that functionality to enable users to download that. Just in case, just as I was showing in case of BZ, so the user can download the recordings. Yeah.
If you have two separate applications using OPFS and you load them at the same time, are they both is there one sandbox, two separate sandbox? How the?
Yeah. So the sandbox is defined by origin. So even if multiple applications, so for example, if OPFS is working on google.com, if you open multiple tabs, yes, they can access the same file system parallelly. So your application has to handle that because you're using multiple tabs to open the same file system. But if it's different tabs with different origins, they wouldn't have access to other file systems. Yeah.
Did you understand right that browser decides how much space can I use? And are there any tools that helps to prevent, for example, eating the whole space?
Yeah, yeah, that's.
As a user, for example, did something wrong. For example, did forget stop recording, and
Oh,
it's
yeah.
always,
Yeah, yeah, that's a really good question, and I have actually thought about it in case of BZ as well, because user might as well forget about it, and it gets into GBs. So Chrome provides you with an API, a quota API, wherein you can determine at certain points that if you're exceeding the quota or like where you are in that quota. So like I mentioned earlier in one of the slides, Chrome lets you use 60% of the hard drive space. If you go over 60%, try to go over 60%, it would error out. It would throw an error. User would not be able to fill up that, go over that. But still, if you want to build, mechanisms so that user doesn't do that, you can use the quota API to detect where, user is. Yeah.
Thanks. One more question. Can operating system detect that this space has been eaten by this OPFS?
Sorry, I didn't get the question.
Let's imagine that you write some application.
Yeah.
And then forget it about it.
Okay.
And you realize that you have not enough space.
Yeah.
How can you understand that and how you can clear it?
Oh, yeah. Yeah, I don't think there is a native way, I guess, to determine that. Probably, some of the, I don't know, I don't use cleaners right now, but if, there was an application earlier, CCleaner, which let you, show that how much space browser is taking. So you might see that, but that's an interesting ask, I would say. I'm not sure if there is a way right now to see how much of the data is being used. I think I can, let's say I can try that. Let's open up the DevTools, because I think it shows in the application section. Yeah, I think it shows here. So if I were to using some of the data, let's try that for Photoshop.com because it was there. So if I were to open up Firefox, this is, where is applications? Yeah. Yeah, so you can see here it's using 4 GB. It's using 4 GBs already. Yeah, so you can see that over here, but it's kind of hidden. It's for the developer, not for the user. Yeah, that's.
Or it's just included in that, and that's.
I'm assuming, because I'm not sure about this, but this includes OPFS and might be including some other things as well. Yeah. But yeah, that was an interesting question. Thank you. I learned something new as well. Yeah.
If you've got two tabs accessing the same file on stream, is
Yeah.
that going to cause an issue?
That might. So generally, if you have a file handle open for a file and other tab tries to access it, it would, for the second time when you try it, it would throw an error that the file is already open. That's how generally file systems work. Like in case of Node.js as well, if you try to open a stream to an already opened stream, it would throw error. But yeah, there is a spec. I was talking about what's next, and that is also something. Let me just close this. So if I go back, yeah. This is also something that has been kind of a popular request that people, users want to read the same file through multiple tabs. Yeah, that's a request as well. Yeah, yeah.
Does it support like watching folders and watching files, like file watchers and stuff?
Sorry?
Does it support watching files and folders to like, know if they change? So if you can,
I actually didn't get the question. Can you repeat that? Sorry.
so does it allow you to monitor a folder? So if anything gets put in there or files get put in there. So say you've got like something on the front end, like writing some files into it, and you've got a work at the back, like I don't know, transcoding something. Does it support that?
The transcoding?
No, sorry. Does it support like watching files being written?
Watching files? No, it doesn't support that right now. Yeah, no, it doesn't. There's not a watcher spec like you can watch it, but I think that's a good use case. People might want to have it, for example, in case of loggers as well, that what's being written. Yeah. Yeah. More questions, please? Yeah.
If you've run out of storage and the user wants to keep writing to it, the user won't think to go and delete it. Most people don't know.
Yeah.
So will it delete the first in, first out? Will it delete the first files you created and override that space?
Yeah, in case it is not if you have not requested for persistent storage, I don't know the algorithm for how browsers handle it, but it might delete whatever it feels like. I don't think there's a public declaration from browsers that it would delete the first file or the last file in the system. I'm not sure, but it would delete something to make space for what you're trying to write to, in case it is not persistent. Yeah. Cool. Any more questions, please? Nope. Thank you then. Thank you for joining the talk. Have a great day.